Alright, grade 8s, today we're going to learn a very important skill called solving proportions. In fact, this skill is going to be your saving grace for the rest of this chapter. If you can figure out this process, which happily isn't that difficult, then much of what you're going to do in this chapter just comes down to solving proportions. So let's get into it. What's a proportion, first of all? A proportion is just a statement that two fractions are equal to each other. So for example, if I write down something like 5 over 12 is equal to 10 over 24, this is a proportion. It's just stating that this fraction and this fraction are equal to each other. They're equivalent. So whenever you have equivalent fractions and you say they're equal to each other, that's a proportion. Now, sometimes you might not know if it's a proportion or not. So this is one type of question. They might write something like you can see down here, 3/5 equals 5 over 8, and they ask, is this a proportion? Are these fractions proportional, in other words? So there are different ways you could figure this out. One thing you could do is get common denominators and then see if they're equal to each other. But there's kind of a useful rule that will help you to very quickly figure out whether two fractions are truly proportional. Here's the rule. It says if a over b, so that's a fraction, if a over b is equal to c over d, if they're truly equal to each other, then what must be true is that AD, or a times d, must be equal to b times c. In other words, this diagonal right here, the AD, must be equal to this diagonal, the BC. So, darn it, what was the one I had up here already? I think I had 5 over 12 is, I can't remember what I had, 10 over 24 or something like that. So what I'm saying is, because of this rule, I would know these are proportional, because if I multiply 12 times 10, I get 120. And if I multiply 5 times 24, I get 120. I get the same thing, so they are proportional. So this first question here is just asking, are these proportional to each other? Is 3 over 5 really proportional to 5 over 8? Are they equal to each other? Are they equivalent to each other? So again, one way you could do this is getting common denominators, or you could change them into decimals. There's all sorts of things you could do. But a fast way you could do this is you could multiply 3 times 8, and you get 24, and multiply 5 times 5, and you get 25. Are those equal to each other? No, they're absolutely not equal to each other. So you put an equal sign with a slash through it. They're not equal to each other. So in other words, these two fractions are not proportional. Maybe what I should do for these ones as well is put not equal. Or if you want, x, not proportional to each other. Alright, let's try the next one. If we multiply this way, I get 6 times 20, which is 120. If I go this way, I go 15 times 8. Ooh, might need to break the calculators out for that one. 15 times 8 is 120. What do you know? You get the same thing. They are proportional to each other. One more. If I multiply this way, it doesn't matter which way you go first. I'll go this way first. 9 times 4, 36. 12 times 3, 36. Yes, those two fractions are proportional to each other. The two diagonals have to equal each other when you multiply. Okay, now the really important skill though for today is not figuring out whether things are proportional, it's when you're solving proportions. So what does that mean? Solving proportion means you're finding the unknown value in a proportion when you only know 3 of the 4 values. So here's 3 examples down here. Take a look at these. Here's a proportion, but you don't know what this m value is, and you have to figure it out. Here's a proportion, but you don't know what n is, and you need to figure it out. Here's a proportion, but you don't know p, and you need to figure it out. So in all these cases, you know 3 numbers, and there's one you're trying to figure out. That's called solving a proportion. There are a whole bunch of different ways that you could solve a proportion. So if you just look at this first one right here, I bet you could figure this out pretty fast. What number must m be? Go ahead, take a look, yell it out. Oh, I heard you. I heard someone yell out 15. How did this person get 15? Well, I think what they noticed was 12 times 3 is 36. So they need to do the same thing up here. What you do at the bottom, you do at the top. 5 times 3 is 15. I got my answer. All right, how about this one? Can you figure out what n is? n should be 4. Now, how could you do that? Well, one way you could do is you could say 10 times 6 equals 60. So I got to do the same to the bottom. What times 6 equals 24? Oh, 4 times 6 equals 24. Or if you want, the other way you can do it, rather than multiplying, is you could divide. You could say 60 divided by 6 is 10. And what I do to the top, I have to do the bottom. 24 divided by 6 is 4. And you can see I'm actually going from right to left this time instead of from left to right. That's fine. How about this one? 4 over 10 equals p over 15. Ooh, this one looks a little bit harder. Can you figure out what that one is? Well, what you might want to do first for this one is, I see that one of my fractions isn't in lowest terms, 4 over 10. I could divide the 4 and the 10 by 2 and get 2, 4 divided by 2 is 2, over 5, 10 divided by 2 is 5. And let's just keep this one the same. Oh, now you can get this quite quickly. 5 times 3 is 15, so I got to do the same up here. 2 times 3 is 6. So my answer is p equals 6. So some proportions can be solved like this, but not all of them. Look at these proportions. 3 over 8 equals 7 over what? What do I have to multiply 3 by to get 7? Or what do I divide 7 by to get 3? Doesn't go into lowest terms. How am I going to do this? Alright, I'm not much for teaching tricks in math, but here's one trick I will give you. It's called cross multiplication. And this is a way that you can find an answer to any proportion. Whether it's an easy one like we did before or really hard ones like this, you can always figure out proportions in this way. So it's a two-step procedure. Step 1, multiply along the diagonal where you know both numbers. Step 2, divide by the remaining number. What on earth am I talking about here? Alright, let's take a look. First of all, the number I'm trying to figure out is this k right here. So if you look, there's two diagonals here, right? There's a diagonal here, and there's a diagonal there. Now, which one of those two diagonals do you know both numbers? Well, that would be this one, 8 and 7. Certainly not this one. It's 3 and k. I don't know what k is. So it's 8 and 7. So the first thing you do is you multiply along that diagonal. So in order to get k, I multiply the 8 times 7. Now, there's going to be one number left over. What's the number left over? The 3. And what you do is you divide by that remaining number. So you would then divide by 3. Divide by 3. So k equals, 8 times 7 is 56 divided by 3. Ooh, that's hard, 56 divided by 3. You know what's going to be very useful for us here? A calculator. You put 56 divided by 3 in your calculator and you get 18.6666666. Oh, 18.6 repeating. That's your answer. Yes, for many of these proportions you're going to get decimals. In fact, I think all of them, the rest of them today, you're going to get decimals as your answers. Alright, they're all like that. The only thing different is you have your unknown in different spots. Here you have it bottom right, here you have it top left, here you have it bottom left, and here you have it top right. And I think I've made a mistake here. Can we say that this is a 2 here? It looks like a Z, but let's say that's a 2, otherwise we can't solve it. Okay, so let's solve the next one. We have our two diagonals. Which diagonal do you know both numbers? That would be this diagonal, 11 and 5. This one has the m in it. That doesn't work. So in order to get m, you're going to multiply the 11 and the 5. There's one number left over, which is the 8. What do you do with that? You divide. So m equals, 11 times 5 is 55, and then divide by 8, and you pick up your calculator and figure out what that equals. And you'll get 6.875. Okay, once you've seen a few, you're probably going to get them all. Here's one diagonal, there's the other. Which one do you know both numbers? That's this one. So in order to get n, you multiply those together, the 11 and the 3, and then you divide by 14. So n equals, 11 times 3 is 33, and divide by 14. Get your calculator, and you get 2.357. It goes on and on and on. I'm just going to write 2.357. I think that's good enough. Last one. In order to get w, what's the diagonal where you know both of them? This one, the 6 and the 2. So we'll multiply to get w. We multiply 6 times 2, and then we'll divide by the number that's left over, which is that 7. We'll divide by 7. So w equals, 6 times 2 is 12. Divide by 7. Get your calculator. 12 divided by 7. It's another decimal. It goes on and on and on. I'm going to just say 714. I mean, I think 3 decimals is more than enough. And you got it. Okay? I mean, I don't know. I got 4 more examples down here, but is it really that important? I mean, you have decimals in them now, but who cares? You have calculators, so whether you have decimals or not, you can do this. Let's highlight what we're trying to find. We're trying to find n, we're trying to find f, we're trying to find z, we're trying to find x. Alright, let's do our diagonal here. Which diagonal do you know both numbers? Right here. So to get n, you have to multiply 3.2 times 1.1. You're going to get some answer, and you're going to divide it by 5. Alright, I'm just going to do it in one go. I don't need to write down what 3.2 times 1.1 is. So I put that in my calculator, and I got 3.52. Oh, what the heck, I'll do it. You get 3.52, and you're dividing it by 5. But, I mean, you don't have to write that down. Just get your final answer. Just divide it by 5, and you get 0.704. Okay, cruising along here. Look for your diagonal. Oh, here's the diagonal right there. 6 and 6. That's fine if they're the same. You can do that. 6 times 6, and then you're going to divide by the number that's left over, which is the 9. Hey, I can do this without a calculator. 6 times 6 is 36, and divided by 9, you get a whole number this time. 36 divided by 9 is 4. Oh, good old whole numbers. Love them. Okay, we're not going to get a whole number this time, I think. In order to get z, what do we have to do? Multiply those two together. That's your diagonal where you know both numbers. 11.2 times, gosh, what is that, 3.7? Yeah, 3.7. And then you have one number left over, which you're going to divide by 23.8. Definitely getting the calculator out for this one. So we're going 11.2 times 3.7, and I get 41.44. I don't know why I'm writing them all down. And then I'm dividing by 23.8. So divided by 23.8, it's probably going to be really ugly. It is. I'm just going to write down 3 decimal places. 1.741. That's more than enough. Right, you can see this method works every time. Don't have to do too much thinking, but it's super important, as you'll see, and there are future sections in this chapter. So, in order to get x, what do we have to multiply? Here's the diagonal where you know them both. 2.5 and 0.22. There's one number left over, which is 8, so we'll divide that answer by 8. 2.5 times 0.22 is 0.55, and then we'll divide that by 8, and you get 0.06875, so I guess it rounds to 69, and that is good enough. Alright everyone, a super important skill. I'm hoping that you can master that, and we'll use it a lot in the rest of this course. Take care. Bye.